Good morning, children. As you know that for weekly test 3, we have to discuss the question paper based upon alcohols and little bit part of phenol as well as electrochemistry. Electrochemistry also little part. Okay, for this discussion paper, already you got the Xerox copies of all these paper. Let us discuss the question one by one. We'll come to the first question. The acidic character of primary, secondary, tertiary alcohols, water and alkyne. What it is? Alkyne is the order of. So what they are comparing? They are comparing primary alcohol, that is RCH2OH, secondary alcohol RCH R dash OH, tertiary alcohol R3COH. We are comparing all these three alcohol acidic character along with water and as well as alkyne. We know very well that terminal alkynes are acidic in nature because of containing what? Terminal hydrogen atom, that is replaceable hydrogen atom. Because of this replaceable hydrogen atom, they are treated as what? Acidic in nature. But as compared to all, the weakest will be alkyne. Weakest will be what, children? Alkyne. That's why we can say that when we are comparing the acidic character, already we said the positive inductive effect, this character, primary, secondary, and the tertiary, can be explained on the basis of positive inductive effect, where all the alkyl group will show positive inductive effect, due to which primary will be greater than secondary than tertiary. All alkyl groups are electron releasing group, but H2O, H and OH, hydrogen shows zero inductive effect, neither releasing group nor electron withdrawing group. Therefore, the acidic character will be what? Water will be stronger as compared to primary, as compared to secondary, tertiary, or with respect to alkyne. Therefore, for the question number 1, correct answer is first one. Very simple way you can write that water is acidic, more acidic as compared to primary alcohol, as compared to secondary alcohol, tertiary alcohol, and alkyne. Primary, secondary, and the tertiary already we can explain on the basis of positive inductive effect. Alkynes are acidic because they contain replaceable hydrogen atom, and the water is H and OH, where hydrogen shows what? Zero inductive effect. Therefore, based upon this concept, we can say that is the acidic character will be in the order of what? Water greater than primary, than secondary, than tertiary, than with respect to alkyne. Than with respect to what? Alkyne. Next question. The best method to prepare cyclohexene. Do you know that cyclohexene is 6 carbon atom which are arranged in a cyclic manner where there is a presence of double bond. Hexene from cyclohexanol. From where? From cyclohexanol. This is cyclohexanol. It can be done by using concentrated phosphoric acid, which acts as a dehydrating agent. It acts as a what? Dehydrating agent, which convert alcohol to alkene. Which convert it into what? Alcohol to alkene. Amongst the following, the HBr react fastest with, we know very well that the attack of HX. The attack of HX will be on the order of what, children? Attack of HX will be depends upon stability of carbocation. Stability of what? Carbocation. Carbocation. Therefore, as we know that the stability of tertiary carbocation are greater than secondary than with respect to primary. That's why to decide the answer, better that we have to write all the structure. Because one thing you need to remember that without writing the structure, don't go for making the conclusion. Because structure itself decide that are they primary, are they secondary, or are they tertiary. Propan 1-all, we know very well that propan 1-all is primary. If I'll write CH3, C and COH, this contain 2 hydrogen atom. That's why it is primary. If we'll see the next one, propan 2-all. Propan 2-all, the center carbon atom are containing OH and another will be hydrogen. It is secondary. Whereas the 2-methyl propan 1-all. Propan 1-all is again primary. Again primary. So propan 1-ol is primary, 2-methyl propan 1-ol also primary, propan 2-ol is secondary, whereas the 2-methyl 2-propanol. Okay, 2-methyl 2-propanol, 2-methyl 2-propanol. This is CH3, this is CH3, and this is OH group. Correct? 2-methyl, carbon atom number 1, 2nd, and 3rd. 2-methyl 2-propanol is what? Tertiary alcohol. And the tertiary alcohol will react fastest. Therefore, the correct answer is 4th option. So you can remember over here that whenever we are dealing with the formation of carbocation, the order of stability will be tertiary greater than secondary than primary. So based upon the order of the stability of carbocation only, we can decide the answer. On what basis we are going to decide the answer? On the basis of stability of carbocation. Tertiary is greater as compared to secondary, as compared to primary. Therefore, HBr react fastest with tertiary alcohol. React fastest with what, children? Tertiary alcohol. Therefore, the correct answer is 2-methyl propan 2-ol. Question number 4. Identify the product in the following. We know very well that to identify X, Y, Z, first you finish off the reaction, then we'll think. Okay. This is what? Propene. CH3, CH, double bond CH2. By adding borane. Remember here, when we are adding the borane, then boron will go to one carbon atom, BH2 will goes to another carbon atom. Or in a simplest way, we can write with respect to water, because anyhow this can be done on the basis of what, children? On the basis of addition of water. That is a basic hydrolysis. Basic hydrolysis in presence of hydrogen peroxide. This reaction will be similar to that of water. We are adding the water. Simplest way to write the answer. Don't go for writing hydroboration oxidation, complicated answer, because we want the answer in a short period of time. Correct? If you are writing the theory answer, that time we'll write over here hydrogen one side, BH one side. We'll go on writing the addition reaction. And during the addition reaction, always carbon-carbon double bond are converted into carbon-carbon single bond. Means alkenes are converted into alkane. Alkenes are converted into what? Alkane. On the basis of this only we are going to decide the answer. Therefore, when alkene, this alkene, addition of water. Better to add water and write in presence of hydrogen peroxide. Hydrogen peroxide follows what? Anti-Markovnik's rule. Anti-Markovnik's rule. And according to anti-Markovnik's rule, as we know very well that negative part of the reagent is added to the carbon containing less number of hydrogen atom. Negative part. Here in case of the water, OH is a negative part. Correct? That's why we are going to get it was what? CH3. CH3. Negative part is because anti-Markovnik's rule. Anti-Markovnik's rule, CH3. And here we are going to get what? H plus and OH minus. H plus and OH minus. According to Markovnik's rule, negative part we are going to add. Remember here, according to, 1 minute, I'll make both the statement, children, once you listen to me. According to Markovnik's rule, when unsymmetrical alkene are treated with unsymmetrical reagent, the negative part of the reagent are added to the carbon containing a less number of hydrogen atom. This is Markovnik's rule. Just now I said this one, Markovnik's rule. Now, according to anti-Markovnik's rule, negative part of the reagent is added to the carbon containing more number of hydrogen atom. Let me clear to you that this is negative part. OH minus is added to the carbon containing less number of hydrogen atom. According to anti-Markovnik's rule, OH minus is added to the carbon containing more number of hydrogen atom. Therefore, the answer is what? CH3, CH2, CH2, OH. Correct? The answer is what, children? Propan 1-ol. The answer is what? propan 1 all. That's why whenever we are going to decide the answer, BH3, sometimes in the reaction, BH3H2O2 will not be mentioned to you. H2O2, in regular classes also we said, when we are adding the acid in presence of mercuric sulfate or by adding water or by adding HX, we are going to follow the Markovnikov rule. But when the question comes related with hydrogen peroxide, we can think of what? Anti-Markovnikov's rule. According to anti-Markovnikov's rule, negative part of the reagent is added to the carbon containing more number of hydrogen atom. Therefore, the correct answer is propan 1 all. Therefore, the correct answer is what, children? Correct answer for the fourth option is propan 1 all. Okay, clear to you? Next question. Question number 5. Acid catalyzed hydration of alkene. We know very well that acid can be act as a catalyst in the hydration. That's why this reaction are called as what? Acid catalyzed hydration. Hydration, as we know very well that addition of water is called as hydration. Therefore, acid catalyzed hydration of alkene except ethene. That means that whenever we are going to add carbon-carbon double bond with the water in presence of acid. In presence of acid, what will be the product? What is the question? Carbon-carbon double bond by adding the water in presence of acid, what will be the product? But they said except ethene. It means that you don't take the example containing 2 carbon atom. What? Containing 2 carbon atom. That's why we'll take the example containing 3 carbon atom. Yes, we'll take 3 carbon atom example. We'll take CH3, CH, double bond CH2. This is propene. Other than ethene, they said, when we are adding the water, acid catalyzed hydration. So it means that you are following Markovnikov's rule. Negative part of the reagent is added to the carbon containing less number of hydrogen atom. We'll get it as what? CH3, COH, H and CH3. Okay. You have added OH to the second carbon atom. To which carbon atom? Second carbon atom. If you are adding the OH to the second carbon atom, OH to the second carbon atom, then what happened? We'll get it as secondary alcohol. Other than ethene, they said. Then we'll take one more alkene, CH3, CCH3, double bond CH2. Correct? I've taken the example like 1, 1, 2, and 3. 2-methyl prop 1-ene. To this, if I'm going to add water, again the same this one, negative part is added to the carbon containing less number of hydrogen atom. Therefore, OH will be added to this carbon atom. What happens? In presence of acid, which act as a catalyst, CH3, CCH3, and this will become it as a CH3, and this will be OH group. If I am taking ethene, we are going to get